Welcome back to the Polytoria beginner scripting series. And today we will be learning about the basics of scripting. Now to start out with, I have two folders. So to start out with, I'm going to show you a couple of essential things to know. To start out with, when you need to save your game, you can obviously save it, and you can save it as a file that you can reopen at any time, or you can publish your game and it'll update for Polytoria. Future me here, I'm just going to interject for a second. If you do not save or publish your game, it will not save the changes after you close your creator. So you always want to either save your game as a file or publish it to Polytoria. Alright, to start out with, a lot of people were having trouble with getting Visual Studio to work. The way you access a script is you insert the script and then you double click it, and it should open up Visual Studio if you have it downloaded. If it's not opening, you can try and uninstall it and reinstall it, or try doing that with the Polytoria creator. And if neither of those work, you could also consult the Polytoria Discord. Alright, to start out with, I have a script right here, and I'm going to rename it to tutorial script, I guess. And I'm going to put that inside of server scripts folder. And I guess before anything, I'll go over this real quick. We have three different types of scripts. Alright, to start out with, we have module scripts. Module scripts are scripts that are mostly used to store and update data. It can be accessed on both the client and server side, although the server side will take priority. Module scripts can be used for a variety of things, but I usually use it to store data or create built-in functions like making a custom tweening module or creating a typewrite effect. Okay, then we have a local script. A local script runs client side, so it's whatever player owns the script, that code will run for the player, and it'll only update. So let's say a local script moves this brick right here. It'll only update for that player. So the other players see the brick still just being in the same spot, while the player that owns the local script sees the brick moving. A server script runs for the server. It's also better to have player data also stored on the server so people can't change their own stats and stuff. So if a player has gold or coins or whatever, you want to check on the server before they make a purchase, just to make sure that matches up. A network event sends a signal between a server script to a local script or a local script to a server script. So it's just messaging between them. A great example of using this would be updating a text for a certain player, or a player, I guess, triggering an event that the server can run. Now, onto the actual scripting, I will go ahead and insert a brick for demonstration. And I will name it test part. I'm going to go ahead and open up my script. So a problem I've seen, or a problem I'm assuming a lot of people are having with Polytoria scripting, is with the way you define your objects. So if I want to create a variable, and creating a variable is just setting a word or phrase to be equal to an object or a number value. Just for example, let me update this. Just for example, local test part is equal to game, and then instead of what Roblox does, with Roblox you can just do game.environment. You can't do that with Polytoria. Instead, you have to use square brackets and quotation marks too to tell the script to look inside environment. It's kind of more of a hassle, but it's definitely giving you a reason to create variables and optimize your scripts. Alright, so now I have this variable that says this word, if I ever use it inside the script, is equal to game environment test part. So if I wanted to tell the script to change something about this part, instead of having to write all of this code out to tell it to look for this, I can instead just set a variable to be equal to this. So instead of writing out all of this, just change the color. I can now just use this variable directly and change the color like this. So that's why we have variables. Another great example of a variable, and a local variable at that, is a for loop. For I is equal to 1, 10, 1, do. Most basic example of a for loop. What this does is it will run anything inside of all of this code. I know there's no code right now, but anything inside of this will loop 10 times because it's setting I to be 1, and it's going to keep going until I is equal to 10, and it's going to add 1 each time. We could add 2 and it'll last half the time and only run 5 times, because 10 divided by 2 is 5. So it's literally just a count up function. And this right here is a variable. You can name it whatever you want. For count is equal to 1. Or you could, I just do I because it's a lot easier for me to recognize it as a number. And then I wanted to do that every second. And we'll just print I real quick. Control S to save your script and test the game. Now if I go into my output, which is the escape menu up at the top here, or you can press the escape key, and then this console right here, and that's how you get to the, oh yeah. Okay, for some reason, at least on the creator, I haven't tested it anywhere else, scripts run twice for me. I don't know why this is. I might ask on the Discord later, but if anyone knows, feel free to comment it down. Everything I've made so far hasn't really been affected by it though, so if this is happening to you, you shouldn't have too much of a problem. But yeah, you can see it counts up to 10, and after that it stops. That's what a for loop does. Now we also have functions. So local function color change. Put our end, make sure you have an end at the end of any function so we can tell the script where to stop. So if I want any of this code inside of the function to run, I have to type out the name of the function. Really quick, if I comment this out, when the game starts, nothing in here will run because we haven't called the function. It's basically creating its own separate script in a way that won't run until we tell the main script to run it, which we can do by typing out the name and putting semicircles. And once you do that, this will run. Now, we're going to give it some parameters because right now we don't have any information. So we're going to require the part that we want to change, actually just the object, because you could probably provide anything, text. Well, I think text color is its own separate thing, but a frame I think uses the same color system. So we'll require an object, and we'll also require the color that we want to change it to. Alright, so when this function is called, we want to take the object, and then we want to do dot color is equal to, also I said earlier that you put square brackets to refer to objects, but if you're referring to a property, which is down here, bottom right, if you're changing that, you do actually use a dot instead of square brackets, because you are no longer looking inside of the part, you're looking inside of the properties. So we're going to set the color to be the changing color, and then when we call this, in order to make sure it works, we have to actually provide an object in a color, otherwise we'll just get an error. So we will provide, well, first we'll create a variable up here, and we'll just name it test part, which will be game environment and then test part. So we'll pass through the test part, and we'll also pass through color.new. Now color.new takes 4 different number values: R, G, B, and the alpha. The alpha is the transparency, 1 being not transparent at all, I believe, and 0 being completely transparent. I'll have to double check that real quick. So if we go into color, you'll see alpha down here, and when it is, so when it's at 0, it is completely transparent, and when it's at 1, it's completely visible. So yeah, I want my part to be half visible. And also for color.new, instead of providing the actual number value, instead what they want you to do is they want you to provide effectively the percentage. You could just divide this by 255 and get a, well, that's how you get a percentage. So you could take your number that you want to change the color of. So for example, I want this part to be this color of purple, and it's going to start out like this. So what I could do is I could type in for R 172 divided by 255, and same with the green and blue. Or I could just eyeball it and say that looks like about 0.6. So if this was 0 and this was 1, this would be about 0.6, this would be about 0.9, and this would be about 0.7. And I could just do that, which is easier, just like that. Or I could put it in brackets, say 172 divided by 255, and change that number for each value. It gives us roughly the same color, but you'll see if I just change it. Also print changing, just so we can get a idea of when it changes. So yeah, you'll see it turns to that lime green, and it changed, and it's about the same color. It's also transparent, about halfway transparency. So yeah, that's how you use color. It's not that complicated when you actually get to know how to use it. So yeah, there's two methods of changing color. You could eyeball it and provide just the base percentage, or you could get super precise and exact and just divide your number by 255. I'm sure they'll eventually make it easier, but for now that's the best method of... And actually you could write out a function for that, because that's what functions are for. So you don't have to keep repeating your number. You could just provide the 3 color values and your alpha, and have your function simplify the color. And then for alpha, it's better just to stick with a percentage. Alright, so I have this simple function written out. As you can see, we will provide or acquire the red, the green, and your blue color, and also an alpha. So that'll be a number between 1 and 250. So instead of having to eyeball it, you can just provide the numbers and it'll convert it into a percentage. That way we don't have to write out all of these divides. Instead, we can just provide the base color, or I guess color number. So yeah, now if we call the color change function, we can provide our test part, and we can also provide simplify color, because remember, we're going to call it, but it's going to give us a color. That's what the return means. So when we call this function, it'll return this new color, and we'll provide 124, just whatever color this is down here. So yeah, 124, comma 124, comma 125, and then a percentage or a decimal 0.7. So anywhere between 0 and 1. So I'll do 0.7, 70% alpha right here. So yeah, we can also create a variable for this. Say, we could say local color, I guess local new color is equal to running this function. So whatever this function is going to give us back, this function right here, new color is equal to this function, whatever it gives us back, which is this right here. We're effectively saying new color is equal to this. But the reason we don't just say that directly is because we can create a function and also use that if we ever want to get a new color and simplify a new color. So that's why we create functions. It's so we don't have to repeat our code. And then we can provide our new color. Does it make it complex? A little bit, but it also saves you a ton of time to have functions like this in module scripts or in local scripts, basically anywhere. So we went over functions, we went over variables. Now we will be going over into a bit more detail over object-oriented scripting or programming. So object-oriented programming, or OOP. It is exactly what it sounds like. It is programming objects. So if you click any part or any object inside of your game, even the game itself, they all have a properties tab, which some of them can be scripted, some of them can't be scripted. Like, you can't affect the game, but you can refer to the game. You can't change any of its properties. Same with hidden and server hidden. So back to the properties on this test part. The properties is everything that makes up the part, basically. It's anchored, which means it's not affected by physics. Its collisions are on, which means you will collide with it and you can't just walk through it. You can turn those off in scripts, and you can also create a spawn with it. That would be a great way of making a checkpoint system where you turn on and off the spawn, the is spawn property. You can also change its shape. You can also change its material, its velocity, which is more of a display property. So if you change the velocity, it isn't going to start moving. That's why we have body position, which I went over in my first beginner episode. And then drag, which just applies drag to the object. Same with angular drag and mass. Gravity, if it's not affected by gravity, it can start just going up like this and that way. But yeah, bounciness, it adds bounciness. I think it's from a scale of 0 to 1. So it's also going to be percentage-wise. 0.6 being 60%. If you don't know, percentages can be represented by decimals just by dividing it by 100. And then obviously we have position, rotate, and also size. You can also change the name and the name. Almost every single property is scriptable. Oh, my script didn't save. I guess make sure you double check, triple check, make sure you save your scripts. One last thing before I go. For some reason, my Polytoria games have not been saving, so please save your games as a file. Alright, that is it for this video. Definitely stay tuned for the next video because we will be going over tweening and how to make a basic tween module that covers all the basics, tweening frames, color, number, and especially parts like this. Of course, this isn't actually tweening, this is just updating every frame, but you get the point. That's what we will be covering next video, and if you have any suggestions, leave them down in the comments below. So yeah, if you like this video, subscribe, leave a comment, and see ya.